What's up, coders? You have been writing Python, smashing those scripts, feeling like a genius. But your code, it's getting long. It's getting messy. It's starting to look your laundry basket aftermath. We need an upgrade. We need object-oriented program. Oh, in the next 12 minutes, yeah, right, 12 minutes, we are crushing object-oriented programming pipe. Forget the textbook. We are going straight to the core. This isn't about syntax, bro. This is about thinking like a software architect. Let's go. The heart of object-oriented programming are two things: classes and an object. A class is the blueprint. Think of it like the master plan for a house or the recipe for a perfect cookie. It doesn't do anything on its own. It just describes what something will be. For example, a car class. It tells us a car will have color, model, and the ability to drive. An object is the thing itself. This is the actual car. This is the actual cookie built from the blueprint. It's an instance of the class. Example, my Mustang and your Tesla. Both are cars, but they have their own specific model, own specific uh, color, or the ability to drive is different. In Python, defining a class is simple. Look at the magic. Class car car1 is car car2 is equal to car. You see, car1 and car2 are now object. Ready to pimp out. Let's pimp them. An object needs attribute. These are the data, the variable that define the object states. How do we give them the object right when we create it? With the legendary, the crucial init method. This is the constructor. It runs automatically every time we create a new object. It sets up the starting attributes. For example, we want to create a class for player. Player has username and level. So we write def init self username and level. Now we should write self name equal to username and self dot level equal to and self the else equal to 100. Now we are going to create an object player 1 equal to player, and the username is Neo and the level is 99. If we print the player one name, the output would be nil. Nil would be the output. We can test it. If we run it, it should be nil. Yes. The output is, so it works and it's true and it's correct. Hey, see that self? It's a reference to the current object being created. It's how the object says, hey, this name belongs to me. Don't forget the self. Python gets cranky. Objects aren't just data. They do things. The functions inside a class are called methods. They define the object's behavior. For example, class dog. Def init self dot name and self dot name equal to name. And this is the method def bark self. What should we do? Print an f string self dot name says wolf. So this is the method def bark self print f string self dot name says wolf. This is the method, and how we use method. We create an object called my dog equal to dog, I don't know, body, and my dog dot bark. Output would be uh, body says wolf. We can test it. If we run it, it says yes. Body says wolf. It's worked, and our dog now can bark. Methods are what turn data into an interactive, reusable component. Need to calculate damage? That's a method. Need to change the car's color? That's a method. They encapsulate the logic inside the object. Clean, powerful, amazing. Now we hit the advanced stuff, the four pillars that hold the whole object-oriented programming castle up. Hiding the sensitive stuff and controlling access. Think of it like the engine of a car. You don't need to know how the spark plugs fire. You just need to press the accelerator, and we bundle up data and methods together inside the class. In Python, we use underscores for suggestion, where, or showing only what's necessary. A phone app's send button is a perfect example. When you click it, the complex networks codes run in the background, abstracted with the complexity. Code reusability, level 99. Why rewrite the same code? Parent class, a superclass called animal, a child class, subclass called or like dog, and cat. The child class inherits all the parents' attributes and methods. Then you just add or change what is specific to child. For example, for dog, we can add bark method. For cat, meow method. For example, class animal. It's a parent class. Dev, eat, self, print, eating. And, and child inherits for class of dog is eating. Now dog can eat. But we want to add bark method. So def bark self and print off. Now a dog can eat because it's a child class and bark. But for example, a cat class, cat object can't bark because it's not dog. It's an animal. It can eat and it can, for example, mew. Just this. We have something called polymorphism. Poly means many and morphs mean form. It's the ability for different objects to respond to the same method calling their own way. A dog object and a cat object. A dog object can and a cat object can both have a speak method. But dog.speak is wolf and cat.speak is meow. Let's look at one final full Python example of a robot class. Class robot def init self I don't know model name and power equal true. Self dot model name equal self uh, is on equal power. And I want to write method for turn on or turn off. Turn off is better. Def turn off self if self dot is on self dot is on will okay. Print f string self dot model name is shutting down else print f string self dot model is already Now it's so. Now we should create an object called R2D2 robot R2 R2D R2D2 dot turn off. We call the method, and now if we click the output, it should say robot R2D2 is shutting down. And after that, if we call it again, it should say is already off. You can test it. So now we can see it says R2D2 is shutting down. Now if we say R2D2 turn off again, it should say what? See? Said R2D2 is shutting down, and after that, R2D2 is already off. Why? Because we call it turn off again. You created a blueprint, built an instance, gave it data, and gave it behavior. You just built a modular, reusable piece of software. Your code is now an organized collection of interaction objects, not just a massive. Time's up. We just smashed the basics of object-oriented programming in Python. This is the foundation for becoming a professional, clean, large-scale software developer. Your code is now an organized collection of interaction objects, not just a massive script. Your homework is this: define a class for something you use every day, like phone or coffee mug, and give it two attributes, like, for example, color and model, and give it one method. For example, for coffee, you can give it pour coffee. Keep coding, keep building, and stay awesome. See ya in the next crash course. Peace.